Hello everyone, welcome to Mifratech. So today in this section I am going to explain forest fire prediction project. So here in this project mainly we are going to predict whether the forest fire will occur in a place or not and what is the percentage of fire occurring based on different using different machine learning techniques and algorithm we are going to do in this project. So here in this section like how to run the project and what is the kind of output you will get I explained already in the previous section. Now in this section I am going to explain only the like backend code, like what is the exact algorithms we use, what is the data set used, how we train the algorithms, which algorithm give the more accuracy, all those backend data I'm going to explain in this section. First we'll go to the project folder. So here this is the project folder. Inside this one, what are the things related to backend code I'm going to explain it. First here forest fire, so this is the exact data set we are using in this project, so it is in the CSV format. Next is forest fire pickle, so whichever the algorithm give the more accuracy we convert into a pickle model, that is a binary format, so that we can directly load it in front end. Next is forest fire prediction, so this is the exact the Python code where the backend code is written, that is training algorithm, all those things. And requirement is normal text document, what are all the packages required both of front end and backend we have written inside this text document. First what we will do is we'll install all the packages required both for front and backend in the command prompt. So how to install? Before that one we'll open this requirements.txt text document. So double click on this one, so it will open in the notepad. See Flask, Numpy, Pandas, PyMySQL, Scikit-learn and sklearn. These are the things required both for front end and backend. Flask and PyMySQL required for front end, and NumPy, Pandas, sklearn all required for backend mainly, and in front end also they may require. So now how to install these packages means just what you have to miss in the search bar type command prompt cmd. So just open this, double click on this one, command prompt will open. Now in the command prompt, so before what we have to do is all the packages need to be installed in the path where the Python has been installed in your system. So what you have to do is just go to the file manager. There you go to local disk C and go to the program files folder. So inside the program files folder there is one more file called folder called Python 36. And inside that one, when you go deeper, there is one more script. So this is the exact path you have to copy, and this path only have to install Python as well as all the package need to be installed in the command prompt. Just copy this path, come to the command prompt here. Now type cd, that is change directory, paste that path, click on enter. Now have come to the path where Python has been installed in my system. Now the command is pip install numpy and hyphen user. So this is the exact command you have to enter. Click on enter. So in order to install all the packages, internet is required if you are doing for the first time. So in my system they are already present, I have installed them, so it will show requirement already satisfied. If you are doing for the first time is internet required, it will show start downloading. After that it will show successfully download. So it is there in my system, it is showing requirement already satisfied. So one more important thing is in this all these requirement, Flask, Numpy, Pandas, these three things you can install any latest version also, there is no harm in it. You can install these versions or latest version, but PyMySQL and sklearn you have to install these two version only, whatever I have mentioned here, because I have used the same version in the program. If you use other version there is a chance of getting error, so you concentrate on these two versions only. So now NumPy has been showing it is requirement already satisfied. So now if you want to install next package, the same command pip install, instead of NumPy type pandas. Now click on enter. So now it will show requirement already satisfied because it is already there in my system. So now two packages I have installed. So next package is Scikit-learn. So how to install that one is the I told for Scikit-learn exact version only have to install. Just go to requirement, just copy this entire line Scikit-learn 0.22. After copying, just come back to command prompt, pip install. After that, just paste that whatever you copied, and after hyphen user, click on enter. So the particular version only be installed. So now requirement already satisfied, nothing but it is already there in my system. So 3 over. Next thing is one more thing we have to install is Flask. So pip install flask, Flask you have to type and hyphen enter user. So now it will start downloading, but see it is already there, so it is showing requirement already satisfied. So finally we left with one more package, that is whatever the package we left here is just go type the same command pip install Flask. So now in the place of Flask is installed, go to the requirement.txt. Here you have to copy PyMySQL, this version only. So after copying, come back to command prompt, just paste that here. So click on enter. So that particular PyMySQL version only be installed in your system. So requirement already satisfied, nothing but it is already there in my system, it is showing. So now I have installed all the packages required both for front end and back end in the program. So now I will close the command prompt. We'll close this requirement txt format also. We'll directly go to project folder. So inside the project folder, now I told what is the file related to backend code is forest fire prediction. We'll open this one. Just right click on this one and edit with ideally edit with 3.6. The backend code program will open in Python shell. So now how to explain this one. So here in the project, the first in the program, the first thing what we have to do is whatever the different packages we are using in particular program, we need to import them. That is the first step. So import numpy as np. So what this line will do means I'm importing numpy library and storing as the alias name np. So why exactly we need numpy means if we are using any kind of like much like mathematical techniques, or you are using n-dimensional array means all those techniques and n-dimensional array will be available inside this numpy. So only I'm importing them. So next thing is import pandas as pd. So now pandas, so what is this pandas means it is a library will help us to whatever the data set we are using in this project, in order to load the data set in the program, in order to check how many rows and columns is there any duplicate values, null values. So in order to do all these data analyzing techniques or data cleaning, all those techniques available inside the pandas library. So I'm importing that one. So next thing is while you are running the program, you are getting any kind of warnings means we should ignore those warnings. So how to ignore those warnings means import warnings, warnings.filter ignores, like import warnings dot filter warnings of ignore. These two lines will help us to ignore any kind of warnings that will come when you are running the program. So next thing is here whatever the data set we will use in the project, the entire data set will not give to train the model. So what we will do is we'll give either 80% or 70% of data in order to train, and remaining 20 or 30% will keep it for the testing purpose. So in order to split the data in the either in 20-80 ratio or 70-30 ratio, we need a technique. So that I am going to import now. So from sklearn.model selection, import train test bit. So this is the exact technique I will use in order to split my data set. So next thing is whichever the what and all the different algorithm we are using in this project, those algorithm I need to import them. See here in this project mainly we'll have whether the forest is danger or forest is safe. So only two output we'll get. We'll call this problem as classification problem. So in order to solve these kind of problems, we need to import classification algorithm. So that is what I'm going to do now. So from sklearn.model and from sklearn.linear model import logistic regression. So this is the one of the algorithm I'm importing. Next from sklearn.ensemble import random forest classifier. Next from sklearn.tree import decision tree classifier. From sklearn.svm import svc, that is support vector classifier. From sklearn.neighbors import k neighbors classifier, nothing but knn algorithm. So from sklearn.neighbors import gaussian neighbors. So all different six classification algorithm I have imported. Next once algorithm imported, you will train them and you will calculate the accuracy. So we have to calculate the accuracy, right? In order to calculate the accuracy, there is a technique available that I am going to import now. So from sklearn.metrics import accuracy score. So this is the technique I will use in later section of the program in order to find the accuracy. So next thing is, so now all the different things required for the project just now I have imported. See here what and all the different packages as of now required I have just imported in the project. That is the first step. One next thing is we have to load the data set, whatever the data set we are using, have to load it in the program. Before that, what is the exact data set we are using in the project, I am going to show you now. So go to the project folder. The data set name is forest fire. So just double click on this one, it will open. See, this is the exact data set we are using in this project. So it is the name of the data set is forest underscore fire, and it is in the CSV format, that is comma separated value. Now what and all the different column is there: oxygen, temperature, humidity, fire occurrence. So mainly based on oxygen, temperature and humidity only, whether the fire will occur or not, values will have. So this fire occurrence is our output column, remaining all oxygen, temperature, humidity are all input column. Here 1 means forest fire will occur, 0 means forest fire will not occur, and there are 100 rows of data present in my data set. So this is the exact data set we are using in this project. Now I will close this data set. We'll go to the project program again. So now we'll load the data set in the program. So how to load it in the program is just pd.read underscore csv. As I told, if you are loading a format file which is in the CSV format, we have to use this function only. So pd.read underscore CSV. So now the name of the dataset forest underscore files with the extension CSV should be enclosed either in single quote or double quote. So I am enclosing with them single quote. Finally, it will load our dataset. I will store in a variable df. So next thing is a print of df dot shape. So what this line will do is it is going to print number of rows and columns present in your dataset. So that is the exact output you will get when you execute this line. Next thing is print of df dot columns. So what this line will do is it is going to print a list of columns names present in your dataset. That is what the kind of output you will get. Next thing is print of df dot head. So what this head function will do is it is going to print starting 5 rows of data from your dataset starting from 0 to 4. So if you want to print more number of data means in the head function, if you type some numbers like 668 or 67, whatever the number you print, if that many rows of data already there present in my data set means within the data set maximum limit, it will print number of rows. If you enter 7 means 7 rows of data, it will print 76 means 76. Like that, whatever the number you will enter, that many rows of data it will print. So next thing is print of df dot describe. So what this describe of function will do is it is going to give some statistical description about each column in the data set, like what is the maximum value, what is the count value, what is the minimum, 70%, 50%, like there's some statistical description about each column in the data set we're going to get as the output there. So next thing is print of df dot core of function. So here core of function is nothing but correlation function. So it is going to give the correlation information about each column, like how each column is correlated with each other. Some value you will get in between -1 to +1. So next thing is in your data set, if you have any duplicate values means you have to drop them. So how to drop the duplicate values means df dot drop underscore duplicates of. So this function will help us to drop any kind of duplicate values present in your data set. In case present means after dropping I will store it in the same variable df. So in order to cross check is there any reduction in number of values, I will print the shape of my data set again. So print of df dot shape. So initially itself I have printed, now also I am printing. So if I compare both, is there any reduction in number of nodes, I will get to know. So next thing is print of df dot is null of sum. So what this line is exactly doing means, so in your data set if we have any kind of null cells like empty cells present in the data set means we have to check is there any cell. How to check means this print of df dot is null of sum function will print number of null cells present in each column. That count value you are going to get as output there. So next, in case they are present means we have to drop them. So how to drop means df dot drop null. See this function will drop any kind of null cells present in your data set. So after dropping I will store it in the same variable df. So after dropping is there again they are present or not, I will now to cross check, I will again check that one. So print of df dot is null of sum. So this up to this much whatever I did, this is just data analyzing, data cleaning or data pre-processing, you can call it anything, I have done with the help of Pandas library. So next thing what I will do is I will separate my output column and input column. I will separately store them in some variables. So df from my data set, the column name fire occurrence is my output column. So df dot fire occurrence I will store in variable y. So my output column is stored in a variable x, y. So now what I will do in my original data set, the output column I will drop. So I will left with only input column. I will store it in some other variable. So if you want to drop any column is how to drop means df dot drop of drop function. The name of the column is fire underscore occurrence. So whether whatever I'm dropping it is a row or column I should mention. So that parameter which will mention means access is equal to 1 means column. So finally I'm dropping my output column. I left with only input columns. I will store it in a variable x. So my output is present in y, input column present in x. So now what I will do is have to split my data set with the help of train test split. So how to split the data set means, now observe here. So train test split, this technique I am calling, the first parameter which I am passing is x, that is my input column, y my output column. So next thing is test underscore size. So what this test underscore size means, in which ratio you want to split your data set. So that value I am giving 0.2 here. 0.2 is nothing but 20%, 0.3 means 30, 0.1 means 10%. So test size I am giving 0.2 means it is going to split data set in the ratio 80-20% ratio. So one more thing is random underscore state. What this random underscore state is nothing but number of times shuffling the data. So now here I don't want to shuffle data. What I will do is I will keep this value as 0 only. So now finally when you execute this line train test split, it is going to give you 4 different output. So those things I am going to store in 4 different variables. So in X train 80% of my all input columns data will be present in X train, remaining 20% will be stored in X train. The same way my output column 80% of data will be stored in Y train, remaining 20% will be stored in Y test. So in this 80-20% ratio now data has been splitted. But it has splitted in 80-20 ratio, but you don't know exactly 80-20% means how many rows it has taken. So in order to cross check, I will print the shape of all these variables. So print of extra indoor shape, x test shape, y train shape, and y test shape. So up to this much I'm going to run and show you the output now. So how to run means just click on run module F5. So if you have made any changes means you have to like save before running. So now you will see what is the output you will get up to this much. See here. First I did is printing the number of rows and column df dot shapes. Here there are 100 rows and 4 column present in my data set. So number of rows and column present in my data set it is showing. So when you do df dot column, the number of column names present in the data set. See oxygen, temperature, humidity, fire, 4 column names as a list you are getting. So when I do print of df dot head, this is the output you are getting. So starting 5 rows of data starting from index 0 to 4, it has printed there. Next thing is df dot describe. So this is the output you will get. So count that's like number of rows present in each column, what is the mean value, standard deviation, minimum, maximum, like that some statistical description you are getting. So when I do df dot correlate function for correlation, this is the output you will get. See how each column correlated with each other. So oxygen to oxygen correlation value 1, oxygen to temperature is 0.51, like that the correlation value will get, the maximum is 1, minimum is -1. So next thing is I drop the duplicate values, I check the shape, again it is 104, initially also 104, so there are no duplicate values. Next I check the null values. So you can see in oxygen temperature, humidity, fire, in each column the null values value you are getting 0 means there are no null values. After that in case present also I dropped and again check, it is 0 only. So now after that I splitted the data set, I check the shape of each variable. So x-train shape is 80 and 3 is nothing but in x-train 80, and out of 100 80% data means 80 rows it has taken 3 columns, because only oxygen, temperature, humidity 3 column present in x-train. 20% means 20 rows 3 columns. White train 80% means 80, nothing is there means only one column, that is fire occurrence column. 20% means 20 rows, nothing is there means one column fire occurrence. So this is the shape it has printed. So now data splitting also over. So next thing what we have to do is we have to create object of each algorithm we are using in the project, and we have to train them and predict the output, and we have to calculate the accuracy. So now I will do that one. So how to create the object of each algorithm is first logistic regression of open and closed the brace. So it will create object of logistic regression. I will store it in a variable model1. So here onwards model1 is nothing but my logistic regression. Next thing is random forest classifier, one more object I am creating. It will take one parameter, that is number of estimators. So that value I am giving 100, you can give 200, 500, any value. So just I am giving 100 here. So that I store in a variable model2. Next k neighbors classifier, knn algorithm object I am creating. It will take one of the parameters, that is n neighbors, that is number of nearest neighbors it will use in order to calculate the predict the output. That value I am giving 3, you can give 3, 5, 7, 9, any value. For a particular value you will get the more accuracy. Next thing is svc. So here support vector classifier object I am creating, stored in model 4. So next Gaussian navy base also I will create an object stored in model 5. Next decision tree classifier model 6. So from model 1 to model 6, all the 6 algorithm I stored in variable model 1 to model 6. So now how to train this algorithm is first model 1 logistic regression dot fit. So this function will help us to train. So model 1 dot fit, which data I will use means only training data. So x train comma y train. So only 80% of training data I am giving in order to train my algorithm. So this line will train logistic regression. Next model 2 dot fit x train y train will store random forest, like that all the 6 algorithm from model 1 to model 6 I am training with training data. So once all the 6 algorithm is trained, next thing we have to do is we have to predict the output from the trained algorithm. So how to predict the output means model 1 dot predict out. So which data I will give in order to predict means only testing data, whatever the 20% data will kept in x test I will give as an input now. So x underscore test. So model dot predict function will help us to predict. So x test I am giving as an input. Finally it will give the predicted output from trained logistic regression algorithm. I will store it in a variable ypred1. So next model 2 dot predict, like that from all the 6 algorithm I will predict the output. I will store it in the output like variable from ypred1 to ypred6. So after predicting the output from the trained algorithm, next thing is which we have to calculate the accuracy of each algorithm. So how to calculate the accuracy of each algorithm is the help of accuracy score, which I have initially imported. Now I will use this technique. So accuracy score of I am calling, the first parameter I am passing is y test, that is nothing but y underscore test, my 20% of actual output, comma ypred1, that is the 20% of predicted output from logistic regression algorithm. So this accuracy score will compare actual output and predicted output, will give some accuracy value in decimal value like 0.53, 0.6 is some value it will give. that I will store it in a variable ACC1. But finally I want accuracy in percentage up to 2 decimal value. So how to print that one is print of accuracy of logistic regression is I want up to 2 decimal point. So wherever the flower brace is there, at that place only accuracy will be refreshed. I want up to 2 decimal point. So colon dot 2f will restrict our output accuracy up to 2 decimal point. So I that format of whatever the accuracy I'm getting, multiplying it by 100 in order to get it in percentage. So finally this will print the accuracy of logistic regression. So next, random forest. So accuracy score of y test. Now it is not y pred 1, y pred 2. That is the predicted output from random forest. Like that, I will print the accuracy of all the 6 algorithms. So logistic regression, random forest, KNN, SVC, Gaussian, NMB, decision tree. So all the 6 algorithm accuracy I have calculated and printed. So now I will show you what is the output we got. See here, from here to here, all the 6 algorithm accuracy you can check. Logistic regression 100%, random forest 95, KNN 95, SVC 95, Gaussian NMB 100%, decision tree also 100%. So out of all the 6 algorithm, logistic, Gaussian NMB, decision tree is giving 100% accuracy. So now I will, among all these 6 algorithm, whichever they gave the more accuracy, I can use as the final algorithm. Here 3 algorithm giving the 100% accuracy, I can use any one of them as a final model. I will go for logistic regression now. So now I will consider my logistic regression as a final model. So what I will do is, whichever the algorithm gave the more accuracy, I will directly convert into a pickle model like a binary format, so that I can directly call it in the front end. So how to convert it means import joblib. So with the help of this joblib only I will convert. How to convert means joblib.dump of. So which algorithm I am converting? Model 1. See here, model 1 is nothing but my logistic regression algorithm. I convert it to binary format as a final model. So the name I am giving is forest fire. Extension should be pkl, that is pkl you have to give pickle model. So after executing this line, and file will be generated automatically. Which file means here in the project folder, whatever this forest fire.pkl you are seeing, it will automatically generate after executing this particular line. So now it is converted successfully into pickle model. So in order to cross check whether it has done successfully or not, we'll load that back converted file and we'll check the accuracy of that one. So how to load it back? This pickle model means joblib.load will help us to load that one. So the name of the file is forestfire.pkl. So after loading, I will store it in a variable final model. So now I will predict the output from that. So final model.predict xtest, predicted output stored in ypred. I will calculate the accuracy. So accuracy score of ytest comma ypred. So finally accuracy of final model up to 2 decimal colon dot 2f in percentage into 100. So after doing this, it will print the accuracy of final model. Now you can check accuracy of my final model is also 100%. So this means whatever the conversion I did, it has been done successfully, because a logistic regression also 100%, my final model is also 100%. So now up to this much is the backend code. Now I trained the algorithm, I calculate the accuracy of all the 6 algorithm, whichever the algorithm gave the accuracy, I convert into pickle model. Finally I finalize my algorithm for the prediction here. So this is what the final output you will get in this backend code. Thank you for watching the video. Thank you.